hardest stuff, though, right?
Sure.
Everything else gets easier, right?
Sure. All right. So we have one quick section to cover before we move on to polynomial functions. And this is a section called Quadratic Inequalities. And we touched on this, and there was one problem on your test that required that you knew how to do this. And I can't even think of maybe 2, maybe 3 people got this correct. It was the one where you had to find the domain of that square root function. And underneath the square root was a quadratic. I'm talking about number
6.
Was it 6? No, number 7. Number 7. So we had done one of these in class. Now let's actually talk. This section is completely dedicated to that type of problem where you're trying to solve a quadratic inequality. So first of all, what is a quadratic inequality? A quadratic inequality is any inequality that has a quadratic of the form ax squared plus bx plus c. And are we all comfortable with the inequality symbols? Greater than, less than, greater than or equal to, less than or equal to? Yes? Okay, so anytime you have something like that, it's called a quadratic inequality. And the question becomes, how do you solve these? Well, I can tell you how a lot of you solve them. You set them equal to 0 and then solve, and that's all you do, which is incorrect. So this is the correct procedure. To solve a quadratic inequality, first solve the corresponding equality. So yes, you do set it equal to 0. That is the first step. But then, once you get those solutions, you have to draw a number line and then create these regions and then check the regions. So if you go back and you look at, I did a video on one of the domain problems. I did it. I showed you there was actually 2 ways to do it. But that's what I wanted you to do on the test. So I'm going to just work through these examples, and then you'll hopefully kind of pick up on it. All right? So the first example, example A, we have 4x squared is greater than 16x. Whenever we have the greater symbol without the equal sign underneath, we usually say strictly greater, which means we're not saying equal, it is strictly greater than the other side. So is this a quadratic inequality? Does it have the form that we had up there? Yes? Okay, notice that in the form that I had up on the notes, all of them that have a 0 on one side, don't they? So what you want to do first is move everything to one side, which means just subtract things from both sides or whatever to get everything to either the left or the right. In this case, I'm going to do everything to the left side. So I'm going to subtract 16x, subtract 16x. Can you combine these two together? No, because they're not like terms, right? So the left side of this inequality just remains 4x squared minus 16x. Over here, you get your 0, so greater than 0. So that does have the form right now of ax squared plus bx plus c strictly greater than 0, doesn't it? A for us in this problem is 4, b is negative 16, and c is 0 because there's no constant term there. So we've got what we need. First step, after we've moved everything over, set it equal to 0. Right. So we're going to take this thing, set it to 0, and solve. This is what a lot of you did on the test. This part of it is correct. So how would you solve this? David, any idea? Factor. You want to factor, like GCF? What do you want to pull out? 4 and an x, okay, and that leaves you with, what do we have? X minus 4, like that. And then what do you do with each of those? Set them both equal to 0, right? You set each of these factors equal to 0. So you set 4x equal to 0, and you set the other one, x minus 4, equal to 0, right? You should get 2 solutions, which are, I haven't learned y'all's names. Y'all got to remember to bring your little things if you have. I haven't. Did you expect I'd learn your name already? I told you in the beginning, I'm terrible with names. Terrible. Come on, y'all got to help me out. Because if you don't have your name thing, I'll call on you first. I'll just say, hey, you. Okay, so what are the solutions? I'm sorry?
0.
X equals 0 and x equals 4. Okay, so that's what a lot of you did. You boxed it, and I took off a lot of points. Because what you're supposed to do now,
Can you take off points if we haven't won?
we did do it, though. We did. We just didn't spend a lot of time on it. I did do an example of it.
We just didn't notice.
You know.
It seemed unimportant. Talk about car washes and death.
Distracted you with all that other stuff. Sorry.
Got us.
Okay, so what do we do with these now? It says now to plot the solutions on the x-axis. See, because these are solutions to an equation, aren't they? All right, so let's plot them. I have 0 and I have 4.
Since it's x squared, the parabola opens.
Yeah, and this is the key to everything now. If we look at this right here, this left side, right, that's a quadratic. If we look at that like a function, right, we studied quadratic functions already. And whenever we set a quadratic function equal to 0, that corresponds to its x-intercepts, doesn't it? So these are actually the x-intercepts of this parabola. Yeah? Now, we don't, that's not what we're asking. We're asking that, you know, when is this greater than 0? What we're really saying is when is the function positive? When is the function above the x-axis? That's what this is saying. Understand that this inequality really geometrically corresponds to that question? So can anyone tell me what this parabola, which is really this one, what it looks like, just generally speaking, the first thing you know about? It opens up, right? Yes? This opens up? And there's only one way to draw a parabola that would open up with these two x-intercepts, and that would be something like this, wouldn't it? Like you couldn't draw it opening down, right, because it's supposed to open up. Why is it opening up? Because A is positive, right? And so now if you just kind of forget everything we've done up to this point, and I asked you, where is this function positive? Then that would be, where is it, you know, you're looking at where it's above, right? And you would say that's what, over here, like that, and then over here, like that, right? Everything there and there. Now, important question though, what about 0 and 4? Do we include them or not?
No.
We do not. Because it says strictly greater than 0 in the problem, right? This is where it was equal to 0. So we do not want those points included in our answer. So our answer is everything, what, from 0 out that way, and from 4 out that way, not including them. So I'll write negative infinity to what? 0, parenthesis, union, parenthesis, 4 to infinity. That's it. Right? That's the answer. That's the answer. You're solving an inequality, right? So what we were saying in the very beginning of the problem, we were saying, hey, look, everyone, 4x squared greater than 16x. Tell me what x's make that true. Does 1 work? Plug in 1. Does 1 work? Is 4 greater than 16? No. Does 5 work? 25 times 4 is 100, right? 5 times 6, so that's 80. So yeah, it'll work, right? So, but that's, what numbers work? All of these. Any of these work. Outside of 4, to the left of 0. Pick any number in those intervals, and you're good to go. Yes?
How would we have known that? I mean, how would we have known to do the inequalities with the question for number 7?
Okay, so in number 7, it's asking for the domain of the function, right?
Yes.
So when you talk about domain, and you have a problem that has a square root in it, what can you tell me about square roots? It has to be, okay, so what was underneath that square root? X squared?
X squared minus x minus 30.
And you just told me that that had to be greater than or equal to 0? Right? So now you have the quadratic inequality. So you just go through the whole system. The only difference between this answer and the one we just did is that you would include those two x-intercepts because it's not strict inequality. Understand? Okay. Now this may not ring a bell the way I did it there. Let me just draw something real quick to see if this one, if you can pull this out of the cracks of your short-term memory. Let's see, do you remember when I did this? And then I partitioned our number line and we picked test points. Do you remember us doing that? Yes. Okay, that's the way I showed you to do it before this. The reason why I'm showing this to you now more formally is because we've studied quadratic functions, so we can use the up-down to get it instead of having to do test points. So go back into your notes. This is the way I showed you, and that's, did anyone do it this way on the test? Yes? Okay, so at least one or two people knew kind of what was up with that. Okay. They weren't distracted by my bus going over the edge of the cliff. All right, so let's see if the next one gets any harder. Negative 2x squared plus 4 greater than or equal to 3x. All right, so we'll go, what we're going to do is we're going to go around the room, and I'm going to ask for volunteers to answer, okay? One person at a time answers. And then when we go back around, that person cannot answer the next time around. Okay, so they're kind of out of the game. So we'll start, but I'll let you two decide. What do you want me to do first here? You want, okay, so can I ask you why you want to do that way and not you do this way? Just curious. Okay, so you don't like the negative here, you want a positive? Okay, that's fine. That's what I would do too. But I'm just pointing out to everyone in the class, you could move the 3x over, but then you're going to have a negative in front of your x squared, which causes some problems for people. So you're choosing to move over to the other side. So when you move over, what's going to be left on the left-hand side, next table? What's going to be on the left-hand side if we move everything to this side? 0, and then tell me what the right-hand side is going to be.
2x squared minus 4 plus 3x or plus 3x.
Okay, so I'm putting in descending order. That's all right? Everyone okay with that? Moving everything to, and just remember the 0's still there, right? Question?
Inequality doesn't change.
No, it does not. When does an inequality change?
If you divide by a negative?
If you divide by a negative or multiply by a negative on both sides. But if you subtract and add, that's okay. Nothing changes the inequality. All right, where are we? My no-name table? No. What should we do? What do y'all think about it? What do y'all want to do with that? What's the next step, I should say? If you move everything over, what's the next step? Okay, yes, right before that though. Set it equal to 0 first. So you're going to step away from this being an inequality and just make it an equation. And I'm going to write it like this. I always like to have the 0 on the right. I'm sorry. When I write an equation, I always like the 0 on the right. So I'm just going to rewrite it like that. Okay, so you said factor?
Yes.
Yes? Okay, so does this one factor? I don't know. No, I just wrote it because I heard factor. So if it's going to factor, then I'm staying at that table. Does it? How would you check? You did? I didn't hear you. So does it factor? What do you think? How would you check? Do y'all have a way?
Wouldn't 1 be 2x?
Yeah, one of them has to be 2x, which means the other one would have to be x, if it factors.
Or can you do the AC method?
Yeah, the AC method would be, that's what I was hoping you'd say. Like, do you have a method to factor?
Oh, then yeah, you can do the AC method.
Okay, so how do you do the AC method? Do you multiply this number times that number?
Yes.
And you get -8?
Yes.
And then you take the number in front 3?
Yes.
I don't know, maybe you make a little table or something, but you're trying to come up with two numbers that multiply to be this and add up to be this. Is that correct?
Yes. No.
Okay, and can you find anything that does that? I don't think it's going to work. What are the only numbers that multiply to be -8? -1 and 8, 1 and -8, 2 and -4, -2 and +4, and that's it, right? There's no way to combine these groups of numbers together in any way to get a 3. So quadratic formula. Yep. So at this point, we would use quadratic formula, right? If it doesn't factor. So here we go. Quadratic formula. My solutions are, let's see, 3 plus or minus the square root. So that's -3, right? -b plus or minus the square root of b squared, which is 9, minus 4 times a, which is 2, times c, which is -4. The entire quantity, everything there, divided by 2 times a. Which leaves me with, let's see, -3 plus or minus square root. 41 in here? Yes? Over 4? Is the square root of 41 a nice number? No, it is not. Is it something you could get on your calculator and approximate with a decimal? Sure, you could. But at this point, I think this is what we call our exact answer. There's no way to simplify this to make it nicer. This is what we refer to as the exact number. So we have two possible answers here. -3 plus root 41 over 4, or the other answer would be -3 minus root 41 over 4. Do you all agree that those are our two answers? Yes? Yes.
If you kept that negative, that'd be 3 plus or minus square root of -23 over -4.
If I would have kept the what?
Negative, if you would have kept the equation negative instead of putting them to the top.
You should get the exact same numbers over here.
I should.
Yes, they should be exactly the same. Were you off a little bit? Was your denominator -4?
Yes.
Okay, and your top was +3?
Yes.
Then that negative down here would go up and turn your positive into a negative, and so it would be the same answer. Yeah, because you're getting this, right? That's what you're getting?
Well, it's 23, -23 in the square root.
Oh, no, that shouldn't be. That should be still 41.
It might have been the way I did the A and B before.
Was your b squared 9? Was your b squared 9? Yeah, there's a sign problem there. 4 times a times c should... You got it? Okay, all right. Yeah, see, here's the thing. Daniela told us in the beginning to move everything to one side. If you choose to do it the other way, we should all get the same answer, right? I mean, that's the only thing that I actually really enjoy about math, is that it does not matter how you go, right? As long as you don't break any rules, everything should turn out the same. It's not like the English language. We've talked about this. How you spell things changes depending on how you're, you know what I'm saying? Yes. It's just like there's something kind of nice about the fact that we should all get the same result. All right, so what are we supposed to do? Where are we? We're at this table, right? Yes. Okay, so what do we do now that we have these two exact solutions? On a number line. Good. Where do they go, though, right? Do you know which one is bigger? Which one goes to the left, which one goes to the right? I'm asking this table in the back for some justification as to why which number goes where. So Any ideas?
Oh,
This one right here goes on the left side. This one goes on the right. So let's see. Square root of 41 is some number, right?
One of those numbers.
Close to 7,
6 something.
close to 6, between 6 and 7? Would you agree with that? Square root of 36 would be 6. Square root of 49 would be 7. It's somewhere in between. So this number is about 6 or so. Negative 3 plus 6 is a positive number. Positive number divided by a positive number should be a positive number. Does everyone agree this is a positive number? In this one, you have a negative number minus another negative number, which should still be a negative number, right? Divided by a positive number? That's a negative number. So guaranteed this is on the left side. All right, so negative 3 minus root 41 over 4. And then this one is negative 3 plus root 41 over 4. Okay, guys, what now?
We check to see if the quadratic goes up or down.
That's right.
Oh, sorry.
You're out now. You're about to say something. Okay, you say check the quadratic to see if it goes up or down. Which quadratic are you talking about?
The original negative, right?
It would be the one where we moved everything to one side. When Daniela moved everything to one side, we had this, right? We had 0 less than or equal to, what was it, 2x squared plus 3. That was it, right? That was what we had. This piece right here is what our function is. That's our quadratic function. And which way does it open? Up, right? So it looks like this.
So you don't go by the original one?
No. You go by the one that you got where you got everything to 0. You go by that one.
Okay.
Because this right side is our function. All right, we're going to go back to this table since we skipped you. What are we looking for in this picture? Are we looking for the same thing we did the last problem, where it's above the x-axis? Where it's below. Why? That's right, because this says less than or equal to, right? We want to know where our function is smaller than 0, right? Below it. Less than 0 means negative. So we want to know this piece right here, don't we? Where that parabola is right here, which is everything between here and here, isn't it? Now, do we include? Yes, we include the endpoints this time. Because it was equality, we can have this equal to 0, so we do want to include those endpoints. Questions, David? Question? Oh, what happened? Are you messing with me or what? I thought that, yeah, that didn't seem right.
But that one's included on the right side too?
Both.
That's more than 0?
Well, the thing is, if we know that if we plug this point into the function, we get 0.
Oh, equals to or more than 0.
Right?
Okay.
So we do want that point, we do want that point. So our answer would look like this. We have a bracket, negative 3 minus root 41 over 4, comma, negative 3 plus root 41 over 4. That would be the solution set. Anything between those two numbers, including those two numbers, would solve the original inequality. Is it what?
I just thought 0 was in between those two somewhere.
Yeah, but 0 has nothing to do. 0 has nothing to do with this 0. I don't know if that's where you're.
I was thinking the number line, I thought 0 was in between.
Yeah, 0 is here. 0 is in between, somewhere.
I thought the original answer was less than or equal to 0.
No, but we want to know where the graph of the function is below 0.
Oh, okay.
We don't want to know where it's to the left of 0. We want to know where the graph of it is below, where the y values are below the x-axis. All right, does this kind of make sense? Yes? Okay, let's see what else is up here. I may not do all of these.
Are we looking for the range on that?
Domain. Well, it's not even the domain of a function. What we're We're saying any number between here, you plug into the original inequality and it's true. It's like me saying this. 2x plus 1 is greater than or equal to 0. Just give me an example of something that would work here. X is 1. X is 0, right? You have a whole bunch of things that would make this true. Anything here would make our original inequality true.
So if it was the function of x equals that equation, would it still be that answer to this one? No, it'd be different, right? It would only be from the...
No. Yeah, you're confusing something. I'm trying to figure out what it is that you're mixing it up with.
Jamaican was left to right brain or something now. So
Yes.
So I
But-
can see if you're looking for the brain.
But when we're saying when is a function less than or equal to 0, we're saying what x values would make it less than 0. All right, let's take a look at, let's do example B from 4.5.4. We have a function, g of x. It's x over the square root of 9x squared minus 9. And the question here is to find the domain. The domain refers to all of the x's that you're allowed to plug into this, right? What sort of issues are we going to run into? The radical, right? We know that what's underneath the radical, this thing must be what? 9x squared minus 9 must be greater than or equal to 0, or else I can't take the square root of it, right? Do we agree? All right, so anybody now, tell me, is there something else that I have to be concerned about? Can't be what? It can't be equal to 0 either. Now, you can, if this is 0, you can take the square root of 0. That's fine. But then you would have division by 0, wouldn't you? Yeah. So we have to now eliminate that part of it. So it's a strict inequality, not just equality, because of the fractional part of the problem. Do you understand the difference? Yeah. So it's kind of like two issues that we're dealing with at the same time. And now this is a quadratic inequality, isn't it? Okay, so we go about solving it. So we first move everything over to one side, which we're already there, aren't we? And we set it equal to 0. And then we plot those solutions. And then we draw a little parabola. And we figure out where it's what? Greater than 0. Can you think you can finish that? Let's see if you can do that on your own. And when you get the answer, raise your hand. I'll come by and I'll check it. Where you got? Where is it? Okay. So, but you have to create your intervals,
Oh, okay.
right? You know what I'm saying?
You want us to find the domain? I thought you meant like find the.
Oh yeah. Okay. No, I want you to take the whole problem. Finish the whole problem. Yep. So I'll give you about, I don't know, 5-6 minutes. See how far you get in 5 or 6 minutes. Anyone have a question? Y'all still working on it? Okay. I'm coming.
Oh, yeah, we're done. You have any?
So, okay, would I be able to split this into 3x plus 3, factor it out and do 3x plus 3 and then 3x minus 3? Mm-hmm. Okay,
Yes,
okay.
you could. You can also just pull a 9 out from the beginning.
Oh,
And there's a couple of different ways you can do it.
Yeah, because I was confused.
You can move the 9 over to the other side and then divide both sides by 9.
Oh, see, this is
There's like 3 or 4 different ways. One of those should be -1.
Should be -1?
Yeah, something ain't right with your quadratic.
Negative b is a negative, so that's a positive. Negative
No, b is 0.
Oh, that's c.
Yeah. Okay, I think that's enough time for it. From what I've noticed, there's some issues in solving this equation, like different ways to do it. And I can think of 3 different ways right now how to do this. One way would be factor 9 out, and then what? Look at that as a difference of squares. X plus 1, x minus 1, and then set each of those equal to 0. So you get 2 answers, 1 and -1. That's one way. Another way would be to take this, move the -9 to the other side, divide through by 9, and then take the square root on both sides. And then when you do that, you get plus or minus square root of 1, which is plus or minus 1. And then the last way, quadratic formula, with A being 9, B being 0, and C being -9. Yes?
I factored it out and got the same thing. I got 3x plus.
Okay, yeah, that was another thing. You could do this difference of squares right here. 3x plus 1, 3x minus 1. Oh, sorry, 3. And then set each one equal to 0, you get -1 and -1. Okay, so remember everyone, these are preliminary concepts. Walking into the door day 1 concepts. That's what we need to recognize, is that if these are the concepts that continually are hindering your progress, then that explains the separation in the class. Okay, half of you understand how to do that and are very comfortable with it. The other half are struggling. So I don't know how you make that ground up, but that's the reality of what would have to happen to get more comfortable with those things. All right, so once we have these answers, what do we do with them? Number line. And then go back to that inequality, which was this, right? This is my function. This is my function f. It's a parabola. It opens up. So it goes like this. And I want it where it's positive, greater than 0. So I want the stuff on the outside edges, don't I? I do not want to include the points because it's strictly greater. So it's this stuff and that stuff. That's where my graph is above the x-axis. So my solution, -infinity to -1, parenthesis, union, parenthesis, 1 to infinity. That's it. Yes?
I don't really get it because I thought the function was like x over the square root. Like I thought it was like an reciprocal.
Yes, no, it is. Our original function, g of x, was x over the square root of 9x squared minus 9.
Yeah.
And what we're saying is, what x's are you allowed to plug into this, right? What x's are allowed, what are not allowed. And what we've determined is that the only thing that's going to cause a problem is if this is ever negative or 0. What we determine is where this thing is not negative and where it's not 0. And this is exactly where it's not negative and not 0. So as long as you pick something from here, this function is defined. Even though we looked at a parabola to figure it out, this was kind of like scratch work in our head that we were doing to solve a bigger problem. Does that make sense?
Yeah.
It's not, this function is not this function.
Will you be able to ask, like, to graph like that and find the domain?
I wouldn't ask you to graph this. This is a little too complicated
Not yet?
to graph. You graph that in calculus.
Oh, okay.
Yeah. That's too hard to graph by hand. Okay, last problem in this section. Then we're going to move on to the next section. All right, so this should look familiar, everyone. A ball is thrown upward from a 200-foot bridge at a speed of 300 feet per second. When is the ball higher than 1,200 feet? Okay, ball is thrown from a bridge. So we had a formula that I allowed you to put onto your formula sheet, right? If you wanted to. What was that formula?
Negative 16t squared.
Was it d of t? Or
Minus dt plus h.
oh, h not. Was it like this? H of t?
Yes.
H of t, sorry. Was it like that one? Yes?
Yeah, plus.
Okay. So what was v naught? It was our initial velocity, right? And in this case, it would be what number there? 300. So I replace the v naught with 300t. What do I replace h with? 200. That's the height of the bridge. This is the parabola, right? This is the parabola that would represent this situation, ball being thrown up, as long as we take air out of it and all that junk. But so this is the parabola. And what are we asking? When is it higher than 1,200 feet? So when is this bigger than 1,200, right? That's all I want to know. Right? When is that function? When is the height of the ball, which is that, bigger than this? And then you can just ignore this, right? And now we have a quadratic inequality. So we just do everything we just did. So first thing I do is move everything over so I have a 0 on one side. So I have negative 16 t squared plus 300t. Subtract, I get what, negative 1,000 when I put those together, greater than 0? So I subtracted 1,200 on both sides. Got that? And now you would try and solve this. You first set it equal to 0, right? And then quadratic formula time probably, right? Yeah. Any questions on the setup of this? All right. So I'm going to start doing the problem by setting it equal to 0 first. I just said I was going to set it equal to 0 and I lied. All right, so that's what I'm going to do. Quadratic formula. Since my variable is t, I'm going to put t equals instead of x equals negative b plus or minus the square root of b squared, 300 squared. 90,000 minus 4 times negative 16 times negative 1,000. All over 2 times negative 16. Everyone following what I'm doing? The numbers are going to get kind of big. Let's see, help me out here. 4 times 16 is 64. It's negative 64,000. So t is equal to negative 300 plus or minus 90,000 minus 64,000, which is 26,000 over negative 32. What is the square root of 26,000? Let's get the approximate value.
161.25.
One what?
161.25.
Okay, does everyone understand what just happened? 90,000 minus 64,000 was what? 26,000? And then you took the square root of it and got 161.25. All of this divided by negative 32. Now we have to find both of these answers. So we have to do two different cases. First, negative 300 plus 161.25 divided by negative 32.
The first one is 4.34.
4.34. Anyone else get that? Was that with the plus?
Yeah, that's plus.
$4.34. So if you do this, if you do negative 300 plus 161.25, and you divide that by negative 32, you should get approximately 4.34. Then what? Do the minus? Negative 300 minus 161.25 over negative 32. And what do you get? 14.41. All right, so we have our two x-intercepts, right? We graph them now. $4.34 and 14.41. And does this parabola that we've been looking at, does it open up or down? So wasn't this the parabola right here? This was the parabola. And we wanted to know where it was what? Greater than? Greater than 0? That's the original problem right there. So this parabola opens down because it's a negative 16. So we know it goes like this. And we know that we want to know where it's greater than 0, right? Yeah, but we moved that thing over, right? So we want this piece in here, don't we? So what is our answer in interval notation? Parenthesis. 4.34, comma, 14.41, parenthesis. And this is seconds. So this ball is thrown upward, right, from a bridge that's 200 feet high. It's thrown up with a velocity of 300 feet per second. It takes 4.34 seconds for it to reach 1,200 feet. And then it keeps going up, right? So it's above 1,200 feet, and then it starts coming down, and now it's below 1,200 feet. So between 4.34 seconds and 14.1 seconds, during that time, it's above 1,200 feet that whole time, going up and coming back down. Make sense? No questions? Okay. All right.
So the 0 at that point would be 1,200 feet. Like if you actually did a graph, X and Y or whatever, 0 would technically be 1,200 feet. Because it takes.
It would be like this. Okay, so I'll draw, this is the graph of what's happening, and then this is the real situation. Okay, so let's say that's the ground. You have a 200-foot bridge, right? Here's my bridge. It's a suspension bridge, okay? Standing on it, you have a ball. This right here is 200 feet. You throw the ball up, reaches a maximum, which would be the vertex, come back down, right? And it hits the ground. 1,200 feet, let's say, is right here. So as the ball goes up initially, right, you throw the ball up 1, 2, 3, 4, at 4.35 or whatever it was. At that point in time, you're now above 1,200 feet. And you keep counting your time, right? It goes up, up, up. And it comes back down. And when it comes back to here, right when it gets to here, it's now 14.41 seconds. and then it continues and hits the ground eventually.
I got that, I was just curious because the 4.3 whatever was an x-intercept. So, you know what I mean?
In a different picture though. See, what gets confusing about this, we're studying one thing, right? And we're using the inequality, moving everything over to one side to get 0. We're using that, which creates a different looking function.
Okay.
Yeah. The original parabola would look like this. You know, go like that. If this were time, and let's say 1,200 feet was here, then this would be 4.35, whatever it was, and then over here would be 14.41. And then the x-intercept would be somewhere else. All right, let's talk about something completely new, all right? For most of the time, not all the time, because some people see this in high school, but for the most part, this is where things start to get a little bit new for people, all right? That can be good and it can be bad. Just depends on how you want to look at it. If it's new, then my expectation is that you haven't seen it. It's bad because it's new, and you may not like it. And we are going to talk about what are called polynomial functions and models. All right, so what is a polynomial function? A polynomial function is the sum or difference, so adding and subtracting, of terms, each of which is a number times x raised to a non-negative integer power. What? So here are some examples of polynomials. So look at this first one. Notice you have a function, you have addition, and then each of the terms has an x in it, right? That x is raised to a non-negative number. What's this x raised to? 1. It's got a number in front of it. And then this one right here doesn't really even have an x in it, does it? Okay, but it's okay to have a number by itself. That still fits into being a polynomial. Does anyone know what this is if we were to graph it?
Linear.
That's a line, right? It's a linear function. How about this one? Does it have x's, pluses and minuses between them? Yes? That's also a polynomial function. But what do we know that better as? That's a parabola, isn't it? Now look at this one. It's cubic. That's a third degree polynomial. It's an x cubed, right? Then you got other x's. There's addition, subtraction. Here's another one. What's the highest power of x in this one? 6. I put it here in the back to see if you would accidentally say 5. All right, so wait a minute. A polynomial function, a line is a polynomial function? Yeah. A quadratic function is a polynomial function? Yes. And so really what it is that you have an entire classification of functions called polynomials, which I'm just going to call polys now. You have all these polynomial functions. They all look a certain way. In here is a smaller group of functions that are linear. And then you have what? Your quadratics, which are your parabolas, right? So every quadratic is a polynomial. Every linear function is a polynomial. But not every polynomial is a linear function. Not every polynomial is a quadratic function. So there's a lot more in here, right? So because of this kind of format, right, the way these look, all polynomial functions will have these two characteristics. They will have a degree, what we call a degree, and they will have something called a leading coefficient. So the degree of the polynomial is the highest power of x that you see, which appears in the problem. It's the actual power. The leading coefficient is the number that is in front of that highest power of x. So let's look at those 4 again. What is the degree of this polynomial function right here? 1. What's the leading coefficient? 3. What's the degree of this polynomial function? 2. What's the leading coefficient? What's the degree of this polynomial function? Leading coefficient? The negative one in front. Degree of this, move. Yes, not that one, right? This, 6. What's the leading coefficient? Negative 4. All right, pretty easy to identify. Everyone see that? All right. So you want me on the next test just to give you like 50 of those, and that's it? Just make the whole test, identify degree and leading coefficient. That's it? That'd be nice, wouldn't it?
Make them like 50 numbers long, right? Then we have to read it.
So look, recall from back in the day that when we were talking about lines, right? We like to look at it as like y equals mx plus b. Do you remember that? Yeah. Y equals mx plus b. What was m again? The slope. And what was b? The y-intercept, right? But mx plus b is just a first degree polynomial function, isn't it? Y equals mx plus b? All right. Y equals mx plus b was a line. The m was a number. The b was a number, wasn't it? And with lines, we gave them special letters, m for slope and b for y-intercept. And then when we got to parabolas, which was a second degree polynomial, right? All parabolas have a degree of 2. Then we like to have a general formula for that, right? ax squared plus bx plus c. That was the general formula. A, b, and c were just numbers, weren't they? So y equals ax squared plus bx plus c was a general format. A, b, and c were numbers. And so now today we're saying, well, wait a minute. We can have a general formula for any polynomial. It doesn't matter how high the degree is. And here it is. And look at this disaster. Okay? Look at that nasty expression. Well, I want you to understand it, okay? Because most people look at that and they're like, this is why math people suck, right? Is because they make things look so complicated. Why does it have to look so complicated? So I want you to think about this for a second, all right? Because there's a reason why it must look that way. And let's talk about what it is first. The general form of a polynomial function has a sub n, which is what? Well, let's see down here. What are a sub n is what? A number, right? Just a number? Just like the a here was a number, and the m here was a number? That a with the subscript n is just a number. Next to it, being multiplied, is what? X to some power, n. Then next to that, added, is a sub n minus 1, which would be another number, right? Some other number? Sitting in front of what? X to the n minus 1. So do you see that the power of this x is 1 less than the power of that x? And then I keep doing this. A sub n minus 2 is just a number sitting in front of another power, right? But now the powers come down again. Do you all see the pattern of the powers going down? So why do we have to write it like this? Why use this subscript stuff? I'm like, why not do this? Like if I wanted to say like a 4th degree polynomial, could I do ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e? Right? I could have done that, right? A is a number, b is a number, c is a number, d is a number, e is a number. And that would, I could call that the general format for a 4th degree polynomial. Why not just stick with a, b, c? Why these subscripts? Why do we say, no, that's no good. We'll call this a sub 4 x to the 4th plus b, not b, a sub 3 x to the 3 plus a sub 2 x to the 2 plus a sub 1 x to the 1, which I don't need the 1, plus a sub 0. Why use this subscript instead of a, b, c, d? They what? No, there's something else. I know, come on, think about it. You can do it. Someone always gets this. Why not continue to use general form A, B, C, D, E? Why use the subscripts instead to just screw you up, right?
Because they're using the same letter?
What's that?
Because they're using the same letter?
Which one? Where? Well, yeah, they're using A, but, right, this is 4. This one's A sub 3. There you go. You won't run out of letters. That's right. So what if I want to give you a general format for a 100th degree polynomial? You want me? Well, because there are polynomials that have a degree 100 that we study. So if I wanted to, and I wanted to stick to this format, I would say what? A x to the 100th plus b, right, x to the 99 plus c. What's going to happen? You'll run out of letters.
You should put that on the test.
Right? You only have 26 letters in the alphabet. Then you could, yeah, you could do like, you know, when you run out of letters, start going AA, right? And then BB or something like that. But look at the subscript. What does the subscript allow me to do? If I want to do a 100th degree polynomial, A to the 100, A sub 100, x to the 100, plus A sub 99, x to the 99. And I'm never going to run out, right? Because my subscript number here can be as big as the degree of the polynomial. So even though that looks nasty, there's a reason why we do it. It's so that we aren't stuck with just 26 letters in the alphabet. All right. Why is this so ugly? I just explained why it's so ugly. All right, now this is going to take a minute. Let's take a look at what polynomial functions look like. This doesn't mean let's go to sleep. All right? All right, so take a look here. This is the polynomial function. You see it right there? This is a degree what? Degree 6, right? Leading coefficient here is what? 1. This is what it looks like. Let me try and zoom in a little bit. Oh, I tried to zoom in just a little bit. That didn't really work very well. Yeah, okay, that's good enough. Can you kind of tell what's happening with this? Doesn't it kind of look like a parabola? I mean, it goes up on the left, it comes down, it doesn't curve and go back up. It does a bunch of crap in the middle, right? And this looks like this comes down here. Zoom it out. Okay, there we go. So it comes down, it does some weird wiggly shit in the middle, and then it goes back up on the right, right? I mean, that's what it does. But overall, it kind of looks like a parabola, yes?
Yeah.
Both sides, you could say, go up. Yeah? Okay. Now I do want to zoom in on this